So today we're starting our 1.3 notes. Our focus question for today is, what is the pattern of change in a linear relationship? So we're going to take the stuff that we've been working with yesterday with Elena, Gilberto, Leanne, and we're going to kind of add on to that and go a little further. So vocabulary questions for today. Dependent variable. A dependent variable is more of your why, and it depends on the independent variable. It depends on the independent variable. Write in the word, dependent variable. It depends on something. And then our second vocabulary word, independent variable, which is like our x. And it determines the dependent variable. So based on what this is showing or telling us, it will determine what our numbers or answers would be for our dependent variable. So if you know one, you can usually determine the other from it, if you know one of them at least. So if we go on, it says, each student found sponsors who are willing to pledge money according to the following descriptions. So we're working on that pledging money. Last time we had that walkathon that we were talking about. I think we're going to go back to that walkathon today. It says Leanne's sponsors will donate $10 regardless of how far she walks. So whether she walks 2 miles or 10 miles, each sponsor is gonna donate $10. And then it says Gilberto's sponsors will donate $2 per kilometer. Every kilometer they will donate $2. And then Elena's sponsors will make $5 donation plus 50 cents per kilometers. So right off the bat, they're going to give them $5. And then say, hey, however many kilometers you walk, I'm going to add on 50 cents for every kilometer. So I know we talked about this before about doing those like color runs, right? Have you ever done a color run? Or there's those Tough Mudders. Any type of charity race, charity event, they always do this kind of stuff. You find sponsors to sponsor you. And so say I were to run in one of these events, I would make a deal with the people that are sponsoring me, and we'll find a price. And say, hey, however many miles I maybe run or walk, whatever I decide to do, that person and I have to be on an agreement for how much they're going to give me. So that motivates me to walk as much as I can because I want to raise as much money as I can. Does everyone understand what they're talking about here? That's what they're doing here. These people want to run or walk as many kilometers as they can because they want to raise as much money as they can to help out whatever foundation or fundraiser they're doing. So that's what they're doing here. It says, what are the dependent and independent variables? Is it our money? Is it the distance? Is it the type of people? Is it the number of people? That's what we're asking right here. Based on what Leanne, Gilberto, and Elena all just told us here, and their deals that they made with their sponsors, what would our dependent and independent variable be, Lily?
Well, the money that they make depends on how much they walk.
Exactly. Did everyone hear how she said that? She said the money they, say it again, the money they make depends on how far they walk. You can't determine how far you walk without the money, or you can't determine the money without knowing how far they walk. So, our money pledge, their agreement that they made, is dependent. It is. And then the distance, how far they walk, like Lily said, is the independent. Now we determine those. If we were to go on here, it says for part A, Make a table for each student's pledge plan. Show the amount of money each of his or her sponsors will donate if he or she walked distances from 0 to 6 kilometers. So on this table in 1A, they gave us the distances. They want to know 0 through 6 kilometers. How much, what's their pattern of what it's going to increase by? So what are the dependent and independent variables for all three of these people? With your shoulder partner, I'll give you about, we'll say 5 minutes. Try to figure out the dependent and independent variables for each one of them and the pattern as to what each person would have in the table. I'll do the first one for you. It says the distance is 0. Well, for Elena, it says the sponsors will make a $5 donation plus 50 cents per kilometer. Well, they're not running any kilometers yet, are they? No, so they're not going to add 50 cents. But right off the bat, what did they say they're going to donate, Lily? $5. So she's just going to have $5 first. And then Anthony Marisi, about Gilberto, it says Gilberto will donate $2 per kilometer. So what should we put for Gilberto's distance for 0 kilometers? 0. He's not walking anything, and all of their money depends on how far he walks. And since they haven't ran or walked anything yet, it's 0. And then lastly, Maria, for Leanne, sponsors will donate $10 regardless of how far she walks. Does not matter. No matter how far she goes, they're giving how much, Maria? 10. So what am I going to put for the 0 kilometers? I'm going to put, whoa, that was a weird. I'm going to put $10 there. So now that we filled out the first column, with your table, your shoulder partners, fill out the rest of this table. I'll give you 5 minutes. Okay, let's come back together. Everyone should be coming back together. Conversations are coming to an end. Stephanie, can you share with me Elena's portion of the table?
Yeah, 550.
Okay, so for 1 kilometer, $5.50.
Yeah.
And what from there?
$6.
$6. Okay, let's go on. Okay. Perfect. An 8. So Stephanie told me we did as a class that $5 for 0 kilometers. They all give you $5 no matter what. However far you run, no matter what, they give you $5. And then on top of that, they said that Lena's, on top of that, 50 cents per kilometer. So that's why in kilometer distance 1 kilometer, she added 50 cents to that. And then in 2, they added another 50 cents. Any questions as to why that is? No. Okay. Joey, help me out with Gilberto's. We know we have $0 at 0 kilometers. But what at 1 kilometer? $2? Okay.
$4.
And then what? 4. 6. 8. 10. 12. All right, I see a nice pattern there. It looks like we're going up by 2s. In Gilberto's agreement, in his pledge, it says that Gilberto sponsors will donate $2 per kilometer, which is why Joey saw that at 1 kilometer, they'll give 2. At 2, they'll give 4. It's going up by 2s because that was their agreement. Good job. And then lastly, let's look at Leanne's. Leanne's is a little tricky. Lily.
So it says that it says Ian sponsors will donate $10 regardless of how far she walks.
Regardless of how far she walks, they will donate $10.
So for 1, it's 10. For 2, it's 10. For 3, it's 10. For 4, it's 10. For 5, it's 10. For 6, it's 10.
It is all 10. Because, like Lily said, regardless of how far they walk, whether it's 1 kilometer, 0 kilometers, 6 kilometers, no matter what, it's always 10. Any questions as to how or why that is that? No? Okay. So now if we go on to our second page, it says for number 2, graph the 3 pledge plans on the same coordinate axis, but use different colors for each plant. If we use different colors, it is so much easier to be able to read and understand what is going on. So I'm going to create the table. We know that we have distance on the bottom and our x-axis because they already told us that. I think these should go by 2s. I'm going to skip a line. So I'm going to do 2, 4, 6, 8, 10. Sorry. 10. And then for my amount of money, which is along the y-axis, I'm also going to go up by 2s. So I have $2, I have $4, 6, 8, 10, and $12. So if you have a black pen, a blue pen, or a pencil, or maybe markers, color pencils, anything like that, grab 3 different colors right now. If you don't, I guess for right now in our notes, you can just do it in pencil and then just label what line is for what person. So if we start, I'm going to do... I'm going to do Gilberto first. At 0, 0 is Gilberto's start. And then we set in our table. I'm just looking at my table and plotting the points that I stated in the table. At 1 kilometer, which is on the bottom here, he goes up to 2. At 2, he goes to 4. At 4, he goes to 6. At 6, he goes to 8. And at oh, I'm sorry. I skipped too many lines. At 1, he's at 2. At 2, he's at 4. At 4, he's at 8. Did I do that now? At 5, he is at 10. And at 6, he is at 12. Everyone see those points? Now I'm going to connect them with my green line. This is where your colorful markers come in handy. There's my line. And if you don't have any colors and you want to just use a pencil, just label it as G for Gilberto. Now if we do Elena, I'm going to do it in blue. At a distance of 0 kilometers, she's already at $5. At 1 kilometer, she's at $5.50. At 2, she's at $6. At 3, she's at $6.50. At 4, she's at 7. At 5, she's at $7.50. At 6, she's at 8. Those are going up by 50 cents, so it looks a little bit more congested in that. They're all close together. Whoa, I moved my line. Let's try that again. If I get blue, there it is. Okay, so now if I make it, and again, I can always make this Elena, I can put an A here. So now last, this one's a little different than what we're used to making. Lily told us that Leanne is always $10, no matter on the distance. So if I go to $10 here, at 0, she's at $10. At 1, she's at $10. 2, $10. 3, $10. 4, 5, 6, she's all at $10. We only plotted our table to 6, so that's why I stopped there. We can continue it on if we wanted to. Oh goodness, I went the wrong way. Okay, let's try that again. Okay, so there's my last one. Any questions as to how we made any of those lines? Okay. Now that it's in different colors, we can also see it a little clearer. So if we go on to 3, it says for each pledge plan, Write an equation that represents the relationship between the distance walked and the amount of money donated. Explain what information each number and variable in the equation represents. So at first where it says Elena, you're just going to write the equation and then an explanation. Break it apart. Tell me what each thing means. So we're going to do P equals for that equaling, or P representing pledge. So there's my P equals. For Elena, what type of equation can we create to show us what our table and what this line means, and even the description they gave us on the front page? Anthony, Marisi, can you help me with this? What kind of equation can we create? P equals what for Elena? P and K. K for kilometers, which is our distance. K what? 0.50. Okay. So I'm going to write it the other way around. I'll do 0.5K. That's for 50 cents per however far they walk. Do we have to add anything else to it for Elena, though? Let's look back as to what they state to us. Elena says sponsors will make a $5 donation plus 50 cents per kilometer. So what else do I have to add to that, Anthony? Yeah, plus 5. So now I can determine how far they're going to walk. Thank you. 0.5 is my 50 cents per K, which is however far they walk, plus $5 because they're all giving me $5 no matter what. Well, not me, Elena. So if we piece this apart, P equals, explaining it, total pledge amount. The K equals kilometers, or I mean you can say distance also. Kilometers or distance. The 0.5, I'll write it right underneath it. 0.5 equals the 50 cents pledge per kilometer. And lastly, the $5 is the amount before walking, because they're all just giving me that before I even walk. Before walking. Let me move this up so you can see it back there. So P is my pledge. Total amount for pledge. My K is kilometers or distance. My 0.5 is the 50 cents per pledge per kilometer. And my $5 is the amount before I even start walking. Now with your face partners, I want you to do the same thing for Gilberto and Leanne. Give me my equations and then explain what each portion of it means. You're going to be using P's for pledge and you're going to be using the K's for kilometers or distance like we did in the first one. So I'll tell you that Gilberto is P equals. Same with Leanne, where I'll have P equals something. So with your face partners, what about like 4 minutes sound okay to work on this? All right. All right, let's come back together. Rebecca, can you tell me an equation for Gilberto? P equals 2K. Awesome. Now can you help me piece it apart? Break it apart, I mean. P equals what? Total pledge amount. Perfect. And then my Q is what? Amount per kilometer. And lastly, the K. Yeah, kilometers or distance, however you want to state it. Perfect. Hands on your head if you got that too. Awesome. All right, Leanne. Let's see. Blake, do you have an equation for Leanne? P equals what? P equals 10. P equals 10. That's all we have to do for it. Can you help me Break this apart. What's our P equal again?
Total pledge amount.
Total pledge amount. Awesome. And we only have to state one other thing. What's my 10 equal?
Amount of money pledged.
Amount of money pledged before walking. It doesn't even affect it. You're right. It doesn't matter if it's before or after. It's still just going to be $10. Hand on your head if you got that. Any questions for any of those? No? Okay. So let's move on to 4. It says for each plan, for 4A, what pattern of change between the two variables do you observe in the table? So we're looking at the money compared to the distance. So for Elena, I'll put A for Elena. What did we see? What does it go up by? Robert.
That it went up by 50 cents.
Goes up by 50 cents. Perfect. And I'll put G for Gilberto. Let's see. Brayden?
Goes up by $2.
Yeah. It goes up, increases, either one, by $2. Perfect. And then lastly, we have Samantha, we have Leanne. I'm going to put it right above Elena here. It goes up by 0, or we can say it remains the same. There's no change. Because it doesn't really go up, it just stays the same. It's constant at 10. So now for B, it says, how does this pattern appear in the graph and in the equation? Okay, so looking at the graphs that we created up above, what does it say for Elena? Elena increases by what? Look at our tables. Lily. Yeah, it's just the same thing. It's showing, it's just reconfirming our table that Elena increases by 50 cents still. It's just we expressed it a different way. Before it was on a table. Now we're looking at it in the graph. Elena, what about Gilberto? I said is by $2. Increases. Let's do this. Increase by $2. And then lastly, we have Leanne again. What is Leanne doing? Gracie? Remember what we said with Sam earlier. If she's going up by 0, she's not really going up. Is there a change? No, there's no change. She's remaining the same. So if we were to go on to C, how can you determine if a relationship is a linear from a table, a graph, or an equation? How can we determine that by just looking? What do we look for in an equation, a table, a graph, to state whether they are linear lines? What's it mean to be a linear line, Eliana? Constant rate of change. That's our key word. We want to see that straight line in a graph. We want to see that, I'll put CROC, constant rate of change. They all should show a constant rate of change. In the graph, we see that by looking at a straight line. And in the equation, it is shown because of what type of equation do we know? for a linear line. We all know, Aiden, please tell me that we went over it yesterday. What's that equation that we always use for a linear line? Do you remember it? Y equals something. For a linear line, we have a slope. So how do we represent that slope in a linear equation? Remember that variable that we use? What does it look like when we have a slope? What variable do we use? On a phone a friend? Robert, what was it? Mx. Our m always represents the slope. That's our constant rate of change. So that's our mx. Plus, we have something else. We have a y-intercept. Blake? B. Mx plus b. We always look for that. When we see an equation, if we see either y equals mx or y equals mx plus b, something in that type of form, we know it's going to be a linear equation. And then lastly in D, they say, does this relationship represent a proportional relationship? All right, we went over proportional relationships yesterday. So Sophia, do they represent a proportional relationship? Yes? Okay. What kind of proportional relationship? What are we looking at? This kind of goes back to our dependent and independent variables and what we're doing here. What's my dependent and independent variable for this? Yep, the money donated or pledged. Okay, and what's my other one? Independent is my distance. So I could say like number of kilometers. The ratio. Let me write this. I'll put the ratio that we will be looking at is the number or the amount of money donated over the number, the distance, the kilometers. It is not a constant, right? For Elena or Leanne. So let's see if we can get through at least 1B for Elena, and then we'll finish up tomorrow. It says in 1B, suppose each student walks 8 kilometers in the walkathon. Now they're telling us our distance of how far we're going. How much money does each sponsor donate? Explain how you found your answer. Okay, well now that we created our equations up above in question 3, now we can use those equations to help us out here. We know our distance. So what is my equation that we created, Philip, for Elena? What is the equation that we created for Elena? We wrote it up above in question 3. Next to Elena's name, we put P equals something. K plus 5. Thank you. So now, Philip, if they told me that each student walks 8 kilometers, how can I plug that into that equation to figure out the profit that they made? Okay, well, what's my K represent in this equation? The distance. So if they told me my distance, couldn't I plug that number into my K and solve for P? Yeah. So they told me it's 8 kilometers. So if I do 0.5 and put my 8 in place of K, now I can solve that. 8 times 0.5 plus 5. So if I were to plug that in to figure out the profit, Robert, what would I get? $9. Elena made a total of $9 when she walked 8 kilometers. And then it says, explain how you get this. Well, we know she gets 50, whoops, I wrote that backwards. She gets 50 cents per kilometer plus $5. We know that. That's why we were able to plug in that type of equation to figure out the equation. To figure out the profit, I'm sorry. So let's try to get through Gilberto. Let's see if we can get through one more. Same with Gilberto. It says each student walks 8 kilometers. Perfect. We know my distance. So Ashley, what is my equation that we created for Gilberto? P equals what? P equals 2K. So now that I know my equation, and now I know what my K is, which is my distance, how can I plug this in to get what my P equals? I can do P equals 2, and can't I replace that, Ashley? I'm sorry? Yeah, I replace it with my 8, because that K represents kilometers, which is also my distance, and that's what they stated up here, 8 kilometers. So if I do 8 times 2 now, Mason, what do I get? I will get a total of $16. And it says explain. Well, he gets $2 per kilometer walked. And we know that by using the equation that Ashley just told us. And lastly, let's do Leanne. Well, what's our equation for Leanne? Zane. Okay, so it says, this is a tricky question. It says, suppose each student walks 8 kilometers. Well, how much money does Leanne get? Zane. She gets $10. Because we said before, it doesn't matter how far she walks. Whether she walks 0 kilometers, 8 kilometers, 10, it doesn't matter. She's going to get $10. So our total is $10. And in our explanation, it says her money is the same no matter what. So we are going to finish up these notes tomorrow. There is no homework today. So keep this in a safe spot so we can pull it back out and finish this tomorrow.